All right.
Is my back in the way where I'm sitting?
You can scoot your desk over if you want to.
Are you videoing right now?
Don't hit it. Okay, so here we go. So today, y'all listen, you're going to like to, because you know most of this stuff. I'm going to maybe talk about one or two things that you have not talked about before, but most of this stuff that you know. Okay, so 2.1, we are going to represent relations and functions. Okay, represent relations and functions. So this whole entire chapter, that's all it's about, is relations and functions. Okay, so the first thing I want to do is I want to define what is a relation. Okay, a relation is simply a mapping. Now, mapping is probably one of the most difficult of all the things that we're going to do. This is probably the hardest one. I can make more kids mess up on a mapping than I can on anything else, okay? So this is the one that we'll practice the most on, all right? But it's a mapping or a pairing of numbers. So like when you pair two numbers together, then that's a relation between that X and that Y, okay? Yes. Okay.
I'll record. My bad.
All right. So it's just a pairing. So here, it's like a relationship. All right. Look at this formula right here. C equals pi d. Okay. Is there a relationship between these two variables, d and c? Yes. What does C stand for?
Circumference.
Circumference. Is there a relationship between the circumference of a circle and the diameter of a circle? Yes. Are y'all going to talk to me? What are y'all being camera shy?
Yeah.
I'm not even cameraing you, okay? I mean, like it's pointed at the board. It's all it sees. Okay. So,
My voice recorded sounds. Yeah, exactly.
please, if I can record my voice that sounds like a country hick, okay, we can all talk on there, all right? So, I mean, I sound like
That sounds like a
crazy
spoon.
Have you heard some of the kids do so?
Yes,
You ever heard
I have.
you ever heard of spoon in the disposal?
Yeah.
That's what I sound like.
Okay, so is there a relationship between the diameter of a circle and the circumference?
Yes.
Yes, there is. The bigger the diameter, the bigger the circumference. The smaller the diameter, the smaller the circumference. You got it?
Yeah.
Okay, Matthew, are you paying attention? All right. So, that's what a relation is, where you just have two numbers. They're generally, we're talking about an X and a Y, and you use one to get another one. Do you agree with that? Yeah. Okay, so let's talk about domain. Domain. When I say domain, don't say range, people. What pops in your head?
X.
Thank you. That's what I wanted to hear. X. Every time I've asked it this morning, when I say domain, what do you think? And they're all like, range. I'm like, no. Okay? So X. What's another name for X? What else could we call it?
A zero.
No, that's why.
F of X.
No, that's why.
Zero?
Yes, but we're not that deep yet.
Independent.
Independent. The independent variable.
The input.
Did I spell it right? I had a hard time with that one. Sorry.
It's a-
Okay. The independent. What?
It's an E.
Of course it is. See? It looks just like an E.
Blood your
All
math
right.
teacher.
So the independent variable, all right? The independent variable. It's the one that whenever you made the T-chart, you picked the X's and then you plugged them in and found the Y's. Because the Y depended on what? What you picked for the X. Okay? What else is it? Think about a soda machine.
Money.
Yeah, so that would be the input, right? It's the input. Yeah, it is the change because that's what you put in the soda machine. So let's think about range. All right, do his partner. Do his partner. If domain is X, what's range?
Wow.
If domain or X's are the independent variable, then the Y is the
Non-independent.
dependent. Okay? If the x's are the input, then the y's must be the
Output.
Very good. Y'all are so smart.
I know.
Okay? All right, now I'm going to show you 4 different ways that I could represent these. Okay? 4 different ways that I could represent these. I'm going to leave a little bit of space up here because I'm going to come back and write some stuff up there, up above each one of them. Okay? But it doesn't have to be a lot of space. So the first way that I'm going to represent them is with an ordered pair. Okay? An ordered pair, like a coordinate. All right? Like these coordinates. -2, 2, -2, -2, and 0, 1. There's a relation right there. There's a relation. 3 points in my relation. Okay? I could also represent them as a table, which you might say, you might call it a what? A T-chart. Okay? Most of the time, if teachers put the T-chart sideways, kids will call it a table. All right? But if you put it up and down, kids will call it a T-chart. All right? But they're both the same thing. And so my T-chart says this same information in a different way. -2 goes with +2. When x is -2, y is +2. When x is -2, y is also -2. And when x is 0, y is 1. Are you with me?
Yes.
Okay. I could also put it on a graph, on a coordinate plane. That's why I picked really small numbers, so I don't have to draw some big gigantic graph. Okay, so -2, 2, put a big fat dot for the old blind woman. -2, -2, okay, and 0, 1. If anybody's going to miss one of these points, this will be the point you miss. Where is 0, 1?
On the y-axis?
Yes, it is. You do not go right or left any because x is 0, and then you go up 1. So it looks like this. Do you agree that all of this is the same information, just presented in 3 different ways?
Yes.
Okay? So the last way I'm going to show you is called a mapping. This is the one that we're going to do more of today because on a mapping, I can like make you miss a problem a lot easier than I can any other way. You're good at these, but you've seen these before, but you don't do them very often, so you're not as good at them. All right? So it's where you have the 2 circles, and this is the input, and this is the output. Okay? My input is my domain, so it is the numbers -2 and 0. My output is the range, so it contains 2, -2, and 1. And then the mapping is actually what shows you who goes with what. Like -2 is mapped to 2. And -2 is mapped to -2. 0 is mapped to 1.
I think we've done this before.
Yes, you have. Everything that I'm going to do today, you have done with the exception of one definition. One definition is the only thing you haven't done. Okay? Now, what if I asked you to list the domain and the range? I'm going to tell you this. When I ask you to list the domain and the range, I want them in proper set notation. If you do not put them in proper set notation, I will mark them wrong. Does everybody understand?
Yes.
Okay. So, domain. Another reason I love the videos, okay, because people say, you didn't tell us that. I'll be like, oh, wait, I'll pull that back up. All right, domain. In proper set notation, I start off with a brace, and then what do I say?
-2.
Any x, such that x is equal to, what is my domain? -2, comma, 0. Does that make sense for you? My domain is any x such that x is equal to -2 or 0.
So if the -2, if there's 2 -2s, you only put 1?
That's right, because that's being redundant. That's like saying the same thing over and over. We don't have to do that. Okay? So that's a good point. If there's more than one of them, we only write it one time. Okay? You only have to say it one time. All right. What about my range in proper set notation? What's he going to say? Any y such that y is equal to what?
1. Wait, -2.
2, -2, 1.
negative 2, and 1. Okay, so yes, this is right. Now, I liked what Michael started to do because Michael started to put them in an order. Okay, so here's what I'm going to tell you. This is like a hint for things, okay? If you have a bunch of things in this range, I would put them in order for the teacher. Because if she's grading a whole bunch of papers and they're not in order, is it going to take her longer to figure out if you have them all there? Yes. But if you order them for her, she's going to skim through it really fast and be happy with you. If you don't order it, she's going to be ticked off at you and looking for a way to take some points away. Do you understand? Yes. Does everybody get it? All right. Very good. So now let's talk about a special kind of relation called a function. A function. Now, y'all remember this stuff, don't you?
Yes.
Yes? Now, here's what you need to know. Remember that when you were taught this stuff was back in Harvey, right? That was, most of this stuff came from your 8th grade year. This is Algebra 1, okay? It is. It's all Algebra 1 skills. So that was back there in Harvey, and, you know, maybe we were struggling a little bit. So, function. A function is a relation. So it's a pairing of numbers, but it's a special pairing, okay? Where every x has only one y. Okay? Every x has only one y. Now, I'm going to say it now, but I'm going to say it stronger, okay? Every x has exactly one y. Okay? I like this word exactly. That means it can have no more, no less, right? When I say he has one y, everybody's like, oh, okay, he's got a y. But if I said he has exactly one y, then you know, does he have 2? Does he have 10? He has one. Exactly one. No more, no less. Okay? So, the first thing I want to do is I want to go up here, and I'm going to take my pink pen, okay, because this is going to kind of be a little cheat for us, all right? And I want to write up here above this, how could I tell if I give you a bunch of ordered pairs, how can you tell if it's a function really, really fast? What are you looking for?
That the x's don't repeat.
Yeah, the x's cannot repeat. If the x's repeat, it's not a function because that x has 2 y's, right? Is this a function? No, I have 2 negative 2's. Why? If I said justify your answer when you said no, what would you say?
The x's repeat.
The x's repeat.
2 negative 2.
I want it better than that. Because look, this is what the definition says. Does the definition say anything about the x's repeating? So that's not a good justification for me.
So negative 2 has 2y.
That's exactly what I want to hear. Okay? So do you see what I'm saying? When I say justify your answer or explain your answer, then you have to do it by the definition. You can't do it by a cheat. Okay? You have to do it by the... Negative 2 is mapped to 2 numbers. Negative 2 has 2 y's. Any of those things. Does everybody understand? Yes. Okay. So a table, how can you tell if he's a function?
Same thing.
Yeah, that's the same thing. The x's cannot repeat. Okay? The x's cannot repeat. So, what about a graph?
They can't be in straight lines.
What kind of line? Like this?
A vertical line.
No, a vertical.
Oh, okay. So if I want to know if a graph is a function, it must pass the what?
Why?
No, must pass the what? What kind of test?
The vertical line
The
test.
vertical line test, people. The vertical, you just told me that. The vertical line test. Okay? It must pass the vertical line test. Okay? So, I'm going to take my straight line. You see my straight line? I got the coolest straight line. What is this?
A stick.
What is this?
Ruler.
It is a porcupine quill. Yes, it is. Okay, it's a porcupine quill. We'll talk about it in just a second. Okay, so let's do a vertical line test, okay? So I'm running it across my graph. If it intersects my graph in more than one place at a time, it is not a function. So as soon as it hits right here, what happens? Beep, he's out, right? Why is he out? Because guys, this X right here has two Y's. He does not pass the vertical line test. He is not a function, okay? Can you pause them?
Oh.
Do you know how to pause it?
Yes.
There is a way to pause without...
Wait, no.
No. Okay, so we're not stopping it. We're just going to keep going. We'll come back. We'll come back and tell the funnies. Okay? And I'll even let y'all see some. All right,
you
so
could-
here we go.
Or you could stop the video and then just like put it together on YouTube.
I
Like,
don't know how to do that.
I can. I'm not gonna do it.
On
But
the-
I'll teach you how to edit.
Okay. Okay, so we're just gonna go ahead and then I'll close it off at the end. We'll have some fun. All right, so look at the mapping, okay? On a mapping, if you want to know if it's a function, okay, y'all look, there's no cheats on a mapping, okay? Like right here, you can look and say, hey, if the x's repeat, it's not a function. If the x's repeat, it's not a function. If it passes the vertical line test, it is a function, okay? But right here, you just gotta ask yourself the question, do you follow the rules?
Wait, can't you know if it's a function or not if two lines go to another?
Okay, so yeah, you can, but that confuses kids. A lot of kids will get confused if I say that, so I never say that.
Okay.
Anything that might confuse somebody, I'm not going to say it that way. But you can know it that way, okay? So here's the rules. The rules are every x has only one y. Does this x have one y?
no.
He's not a function. Do you see what I'm saying? This x has one y, this x has, no, more than one y. He is not a function.
Correct.
Okay, so which one was the most difficult? The mapping. So let's study some mapping ones, all right? So this is example 2. I'm not really sure where example 1 went, but I'm thinking that it was probably one of those things up there and I expounded on it. So all I want to do is I'm going to draw some mappings and I want you to tell me if it is a function or not, okay? So I'm going to draw them. I'm going to tell you what's in the input and what's in the output because once I draw them, they're kind of hard to see, all right? So in the input, you have the numbers -3, -1, 2, and 4. -3, -1, 2, and 4. In the output, you have 2, 3, and 4. And it's mapped like this.
It is a function.
Very good. So, do you understand the thing about the two line things, Montana? You see what I'm talking about? Like
Yeah,
some
but-
kids, I know what you're saying, okay? You're saying if it comes from this one, yes. But some kids will be like, no, that's not a function because it's got those two lines. So, that's not. So, I just say, does he have one Y? Yes. 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 Do I care that it's the same Y? No. It's a function. Are you with me? Okay, so here's your next one. Are you ready? Now, what's the object of this game? I'm trying to trick you, okay? -3, -1, 2, and 4. Same input. -3, -1, 2, and 4. My output is 2, 3, 4. 2, 3, 4. I kind of scrunched up the 3. So he looks like this.
Nope. That X doesn't have a Y.
Why is it not a function? He has one Y, one Y, one Y, one.
Nope.
Oh, he doesn't have. That's what I mean by the word exactly. Do you see what I'm saying? Every X has exactly, no more, no less. He doesn't have a Y. He is not a function. Okay? Here's your next one. 1, 2, 3 in the input. 5, 6, 7, 8 in the output.
Yes.
No, it's not a function.
Does he have one y? Does he have one y? Does he have one y? Is it a function? Very good.
Oh, so if the x is missing, then
right.
it's still a function as long as
Every
the other
x has exactly one y. Then he is okay. Do you understand what I mean about following the rules? That's why I think it's easier on a mapping just to say, do you follow the rules? Okay, so here's the last one. -2, 1, and 4. -4, -1, 2, and 3. And he's mapped like this.
No.
Justify your answer.
The one has 2 I's.
Okay, so 1 has 2 y's. This guy, he has 1 y. Oh, no, he doesn't have 1 y. He has 2. 1 is mapped to -1 and 1 is mapped to 2. So no, this is not a function. Okay? So now we're going to do some graphs. Okay? Now we're going to do some graphs. I'm going to draw a graph up here and you're going to tell me. Now on a graph, what am I looking for it to do? Pass the vertical line test. As long as he passes the vertical line test, we know he is a function. Okay? So here's the first one. Does he pass the vertical line test?
Yes.
Yes, he does. He is a function. Okay? What about this guy right here?
Yes.
Oh, every day, even on Sundays. Okay? What about this dude?
No.
Oh my word. People, like you do the vertical line test and as soon as you like touch him, you hit every stinking Y that there is. That one X, he has every Y. So, oh, no way. No way. Okay? What about this guy right here?
Yes.
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 No.
Yes.
Yes.
Okay.
No.
So let me explain something to you, okay? Can something be a curve and straight?
Yes.
Y'all, listen to me. If it's a curve, it's a curve. Yeah, it can't like all of a sudden have a straight part in it. If it's a curve, it's a curve. So if this is a curve right here, does it ever just go straight up?
No.
Okay, is this a function?
Yes.
Yes.
And whenever I took Algebra 1, we were doing stuff like this, and we did the test, and it was a parabola, and I said that it was one, and I got it wrong. And she said, no, it doesn't. I was like, no, it literally doesn't. Here, look.
No, it doesn't. Y'all look, when it looks like, I even drew it so it kind of looks like it goes straight up, but really it's a curve. And if it is a curve, it is always a curve. And so when he goes up, he's ever so slightly going out. Okay, so he will pass a vertical line test. What about this parabola?
No.
No. Once you pass that vertex right there, you're bumping that parabola at the top and the bottom every single time, forever. So no, he is not. What about this guy right here?
No.
No. Once you pass the point of tangency, what? This is not geometry. Then you are bumping that circle at the top and the bottom all the way across until you reach the point of tangency over here. Okay? What about this dude? Yeah, just a little slanted line, okay? Just a little slanted line. He's going to pass it. All right. Anybody got a question about a function? Can you tell if something is a function if I give you a list of points,
Yes.
a T-chart,
Yes.
a graph,
Yes.
and a mapping?
Yes.
People, those are going to be test questions. Should those be hard?
No.
Some of you are going to miss them. They're not hard. All right? So, pay attention. All right, so here we go. We're going to define something. Now, you have never heard of this. All right? So, let me find the top of my paper. This is called a one-to-one function. Now, look, this is what I love about math people. They're like, man, they say it like it is. You know Miss LaBeouf, right? She says it like it is. Sometimes she says it like it's not. But anyway, all right? We say it like it is. It is a one-to-one function. So first of all, what does it have to be? A function. People, listen to me. If it is not a function, function, can it be a one-to-one function?
No, of course not.
Y'all, on the test, this is going to be test questions. It's going to say, is this a function? And you're going to say yes or no. And then it's going to say, is it one-to-one? And then you'll say yes or no. Some people go, is it a function? No. Is it one-to-one? Why, yes it is, Miss Davis. I'm like, what? It's a one-to-one function, people. If it's not a function, it can't be a one-to-one function. Okay? Like if it's not a dog, if it's a cat, can it be,
Not a cat.
yeah, a dog? I was trying to think of a type of dog. A weenie dog? No, people, if it's not a dog, you see what I'm saying? That's just crazy. If it's not a function, it can't be a one-to-one function. So what is a one-to-one function? First of all, every x has exactly one y. And what?
Every y has exactly one x.
That is exactly right. And every y has exactly one x. Okay? So this guy, not only does every x have one y, but every y has only one x. So what if now that's not hard to do on a T-chart or a list of points, is it? The x's can't repeat, and what else? The y's can't repeat. But what about a graph? Well, first of all, we know he has to pass the vertical line test, right? Oh, there you go. He has to pass the vertical and the horizontal line test. He has to pass both of them, okay? He has to pass both of them. All right, so let's go back and let's look at these things over here. And let me find my paper. Okay, let's look at these guys that we've been talking about, and let's see if they're one-to-one, okay? So first of all, let's make this clear. Are any of these one-to-one?
No.
Why?
Because it's not a function.
They're not functions, people. The x's repeat, okay? They're not functions. So let's go down here and let's look at these first. I'm only going to look at the ones that are functions, because if it's not a function, it's not one-to-one. So let's look at this guy.
No.
Why?
The y has two x's.
Who?
4.
4 has two x's. Is he one-to-one? No, he's not 1, 2, 1. Okay, we're skipping this guy. Why? He's not a function, people. He's obviously not one-to-one. What about this guy?
No.
Oh, why?
8 doesn't have an x.
8 doesn't have an x. Do you see? He's the same problem that this guy had over here with being a function. Okay, so he's not one-to-one. He's not a function. Now what are we doing? What are we testing with?
The vertical and
Vertical
horizontal.
and the horizontal. So he passed the vertical line test. Is he going to pass the horizontal line test?
No.
People, he's not. Good night. You pass those. First of all, if you hit those two things, they hit at the same time. But here you got 4. All right? So no, he's not. What about this guy?
No.
Oh, like you hit the buzzer there. Okay? No. He's not a function. What about this guy?
No.
Does not pass the horizontal line test. As soon as you pass that vertex, you're bumping it 2 places. No. What about this guy?
Yes.
Yes.
Yes. He passes the vertical line test and the horizontal line test. Okay, so far you should understand about mappings. Can you tell me if something's a function?
Yes.
Does it matter how I give it to you?
No.
Okay. Can you tell if it's a one-to-one function?
Yes.
Yeah.
Okay. We're going to do just a couple more things. So the first thing is, what do I mean when I say it's an equation in 2 variables?
That is an extra law.
Yeah. Oh, that's what it means, okay? It has an x and a y, or it could have an a and a b. It just means that it has what? 2 variables. That's exactly what it means. Okay, so what about if I asked you if something was a linear function? Okay, what if I asked you if something was a linear function? First of all, if you graphed it, what should it look like?
A line.
Yeah. If you graph this dude, he better be a line. It's a linear, look at the word. Linear. Guess what it has in it?
Line.
Line. So a linear function, if graphed, looks like a line. It's not always easy to graph them because in order to graph them in your calculator, you have to solve for y, right? Are you with me? Okay, so sometimes you can graph them and sometimes you can't. So here's what I'm going to tell you, that a linear function can only have an x to the first power. It's usually just going to be written as an x. It's not going to say an x to the first. It's just going to say an x. Okay? So if it has just an x, then it's a linear function. Can it have an x squared?
No.
Yes.
People, what did I just say?
It can only have
I said it can only have an x. It can't have an x squared. If it has an x squared, is it going to look like a line when you graph it?
No.
It's going to be a parabola, isn't it? You're out. What about an x to the third?
No.
No, that's called a cubic equation. It looks like what we call an S-curve. Some of y'all might be studying about that if you're doing that optional project. Okay? So you can't have x to any power except what?
1.
1. Okay? What about an x in the denominator? Could I have an x in the denominator? Is that going to be a line if I graph it?
No.
No. This is called a rational function. Okay? You know what the word rational means? Fraction. Okay? If you see the word rational in math, it's a fraction. Okay? So there it is. And I got an x in the denominator. Not just a fraction, but if you have an x in the denominator. This is what it looks like. Okay? Looks like this little curve up here. Looks like this little curve down here. Okay? It has these things called asymptotes. Asymptote. Sounds like a bad word. Like you could call somebody an asymptote and not get in trouble. We draw an asymptote with a dotted line. It's not really part of my graph, but it tells me what's happening with the graph. Because here's what an asymptote is. An asymptote is a line that your graph approaches. It gets closer and closer and closer to it, but it never ever gets there. Okay? So up here, this graph, this curve right here, is getting closer and closer to the y-axis, but it never ever gets to the y-axis. Down here, it's getting closer and closer to the x-axis, but it doesn't ever get there. It's like if I were walking to the wall and I walked halfway every time, would I ever get there theoretically? No, you would never get there. Now, obviously, my feet would at some point get to the wall, but theoretically, you never would. The same thing's happening out here and happening out here. People, is that a line?
No.
No, that's not a linear function. It's a rational function. Okay? What about the absolute value of x?
Yes.
Let me show you what it looks like.
Oh.
Is that a line?
No.
No, that's a V, people. That's a V. So, no. Can't be an absolute value. That's a linear function. Got an X? You usually have a Y. Okay? All right, so anybody have a question?
No.
All right. So the next thing we're going to start, we're not going to finish, we're just going to do this one thing. Function, this is what we're going to talk about tomorrow. Function notation. I only like this one thing and then a little extra thing from our book. So tomorrow we're going to start talking about function notation. Okay? Anybody got a question?
No.
All right, I'm going to stop the video.
Yes.